In this video, we are going to look at undergrad versus grad solution for an integral, which is integral from negative infinity to infinity 1 minus cos x by x squared dx. The undergrad solution is via Laplace transform and the grad solution is via MAZ identity. Okay, so let's begin by Laplace transform. But before that, we can see that it's 1 minus cos x, which is the standard formula, which can be taken into the other form, which is 2 sine square x by 2 sine square x by 2 by x square dx. Yeah, and then now the next thing that can be done is since these both are even function, we can take two. If the integral is from negative infinity to infinity, and we have f of x dx, and if f of x is even function, we can make it to 2 times integral from 0 to infinity f of x dx. So we'll use that, and that will give us integral from 0 to infinity sine square x by 2, and we will have here 4, so that goes denominator to give us x by 2 whole square dx. Now you can let y as x by 2, that will give us integral from 0 to infinity sine square y by y square times dx is just 2 dy. Now this is a kind of Dirichlet integral. Yeah, this integral from 0 to infinity sine square y by y square dy. And let me tell you, like, this is kind of standard integral, though I will solve it, but integral from 0 to infinity, like sine square x by x square dx, this is just pi by 2. And we also have other integrals, like integral from 0 to infinity. Oh, I'm sorry. Yeah, okay, let's go. We are here at rock. Sine square x by x square dx is just pi by 2. And the other integral from 0 to infinity sine x by x dx, this is also pi by 2. Yeah. And the other integrals, like integral from 0 to infinity sine ax by x dx, this is actually the same integral, and we can have a over here and a dx over here, and that will give us ax dx. Yeah, so that's same, and it is also pi by 2. So these are actually pi by 2, and so we can directly write here pi by 2 if we want, and that's give us pi. So, and pi is the answer for this integral. But we are not going to stop here. We are going to proceed further, since we have not used Laplace transform till now. Yeah, it's on the way. And now after this one, basically to simplify this, we can first use integration by parts. Okay, so we can use integration by parts with y square as a, u, and sine square y as b, and that will give us no, this was u and this has b. Okay, so sine square y times minus 1 by y integral from 0 to infinity. No. If I do 0 to infinity, I will not evaluate this integral at 0. So let us take this 2 out, and let us make it from minus infinity to plus infinity. This can be done since this is even integral. Yeah, both are even functions. Yeah, okay. So now if we do that, from minus infinity to plus infinity, and minus integral from minus infinity to plus infinity, this will be just 2 sine y and cos y, and the other one will be integral of minus 1 is just minus 1 by y dy. Yeah, now if we evaluate this at infinity, sine of infinity lies between 1 minus 1, only between 0 to 1, but we have y in the denominator, which is really big. Yeah, so this will be just 0 and then minus 0. Okay, so that goes to 0 obviously, and now we can take this minus one outside, which gives us integral from minus infinity to plus infinity, and then sine 2y by y dy. Okay, and now you see this is another form of directional integral up over here, sine ax by x in dx. This is also pi, yeah, this is pi because for 0 to infinity it does pi by 2, but for minus infinity to infinity it's actually pi. Okay, take care of that. And now if we have that, we can just make a change. This is sine 2y, we can add here y 2 and also here 2, and 2 dy becomes d of 2y. Yeah, okay, and now after this we can replace 2i by g, and then if we do g equals to 2y, we have integral from minus infinity to infinity sine g by g dg. Now after this we can use Laplace transform. Laplace transform, yeah, but for that we first have to introduce a new integral from minus infinity to infinity, and then sine of tg by g dg. Now we can do Laplace transform in the world of t. If we do Laplace transform in the world of t, these aren't going to matter, these limits of integration. Also 1 by z will not matter since that's a constant, and this will be in the world of t, g is a constant, so that will be g by t square plus g square. Yeah, this will be a constant. Okay. Yeah, it is. And now we have dg. But is that all? Yeah, this is all for now. Yeah, is it? Yeah, it is. Okay, and then Laplace transform of I of t will be integral from negative infinity to infinity. G cancels out, and 1 by t square plus g square dg. And now it's in the world of g, so t is a constant, so we get 1 by t tan inverse of g by t, and going from negative infinity to infinity. So this is 1 by t. At infinity it's pi by 2 minus pi by 2, so that's plus pi by 2. So this is pi by t. So Laplace transform of the integral gives pi by t. And now the integral I of t will be just inverse Laplace transform of this thing. Yeah, and the inverse Laplace of 1 by s or 1 by t is just a constant, so this is pi. So I of t for any value of t is pi. Yeah, we have proved this already. So this integral was to be pi, and we got the result. And now for t equals to 1 is what I want. So I of 1 is also pi. So our required integral, this one is pi, and that's our solution. Yeah, pi is our solution. Now there is other way that's way easier than this one. The other way is from MAZ identity. So before we begin, let me tell you about MAZ identity. So it says that integral from 0 to infinity of f of x g of x dx, this equals, oh sorry, but we will have our progress recorded, so there is nothing to worry about. No. Yeah, okay, about MAZ identity. Integral from 0 to infinity f of x g of x dx. This integral will be equals to integral from 0 to infinity Laplace transform of f in the world of y, Laplace inverse transform of g in the world of g in the world of y dy. So one of them is Laplace transform, other is inverse Laplace transform. So this is a MAZ identity, and if we use this one, our integral from 0 to infinity 1 minus cos x by x square dx, this will be transformed to integral from 0 to infinity 1 minus cos x will be 1 by s minus 1 by s square plus 1, and the 1 by x square will be, this is just gamma 2 by x to the power 2, So that will be 1 by s. Okay, so that is 1 by s, isn't it? Isn't it? So this was just gamma 2. If the Laplace transform, for Laplace transform to be gamma 2 by x to the power 2, we need to have, so sorry. One not. I think the one that's not the answer. That's not the answer. That's not the answer. For Laplace transform to be, gamma 2 by x to the power 2, we need to have, of course, we need to have Laplace transform of e to the power minus s xt times, we need to have x to the power 1. Yeah, so this is actually only s, not 1 by s, and that's a mistake. Delete. Yes. Yeah, we need to have this s over here and then ds. And now this one, integral from 0 to infinity. This will be. Is it? Yeah, it is. Now 1 minus s. 1 minus s. But how come there be s? How come there be? Gamma 2 by x squared is there now. Okay. Just a minute. Oh, here we have cos x, but here I should have s as well. Yeah. For Laplace transform of cos x, there's also s variable in numerator, and for inverse Laplace of this one, it's just s. Okay, that's now fine. And then we have 1 minus s squared by s squared plus 1 ds. I hope you get it. Laplace transform for 1 minus cos x is this, and Laplace inverse transform of x square is 1 by x square is this thing over here. Now after this, we can just take LCM, and this will be s square plus 1 minus s square by s square plus 1 ds. This gets cancelled out, and the thing is tan inverse s going from 0 to infinity, so that's pi by 2 minus 0, so that is pi by 2. Okay, so now we have this going from 0 to infinity of this integral is just pi by 2, and what we are asked is from minus infinity to plus infinity. So now from minus infinity to plus infinity, 1 minus cos x by x squared dx. We know that cos x is even, 1 is even, x squared is even, so overall it's even. And so that's 2 times the integral that we found out, so 2 times pi by 2, so the answer is pi. Yes, we have solved this using 2 ideas. Now I hope you enjoyed the solutions really well and you have learned something, and look forward to seeing you in the next video. Thanks for watching. Do like, share, subscribe the videos if you like them.